Hi there, and welcome back to the channel. In this video, we are going to be discussing redox reaction. Redox reaction is a very important aspect of electrochemistry. Now, in order to understand this aspect of electrochemistry, we must understand what is known as a spontaneous reaction and a non-spontaneous reaction. Now, I have made a video on that, and I am going to link it in this video description, but just to reiterate, we have talked about the fact that spontaneous reaction is a reaction that goes on by itself, that happens by itself without any impulse, without any force, any impetus. Is that okay? So it just happens by itself, and that is because it carries a Gibbs-free energy of what? Or a negative Gibbs-free energy. While a non-spontaneous reaction is one that happens by an impetus. It means a force, it is driven by a particular amount of energy. While the one that just happens on its own without being driven by any external force or external impetus is a spontaneous one. And a non-spontaneous reaction has positive Gibbs-free energy, while a spontaneous one has a negative Gibbs-free energy. I repeat, spontaneous reaction, negative Gibbs-free energy. For example, a spontaneous reaction is such as we have here. If a ball were here, it has a higher potential energy. So what will happen? It will by itself, it can roll down this hill. But for this ball to ascend this hill, it needs an impetus to drive it there. So this reaction is going to have a positive Gibbs-free energy, while this one is going to have a negative Gibbs-free energy. So this is called spontaneous because it happens on its own, while this is called what? Non-spontaneous. All right. And the opposite is the case for the electric potential. This is going to have a positive electric potential because it is happening on its own, and this is going to have what? A negative electric potential. Now, what a positive electric potential means is that it can generate electricity at the end of the day, because this is what electrochemical cell. This is the property of what? An electrochemical cell. An example of an electrochemical cell is the voltaic or galvanic cell. The voltaic or galvanic cell. Why this is has a negative electric potential. Why? Because it has a negative electric potential first, and the example is an electrolytic cell. An electrolytic cell is a system in which electrolysis happens. So an electrochemical cell is a system that converts chemical energy. It converts chemical to electrical energy. Why this one does the opposite? It converts electrical energy to chemical energy. All right. Now, here we are not talking about electrolysis here. We are talking about redox reaction. I'm going to link the video where we discuss electrolysis in the video description also. Now, what is a redox reaction? It has been defined in so many ways. But I'm going to use two major definitions that you should that are going to help you in balancing redox reaction, because that is our end goal in this video. Now, the first definition is that redox is gotten from two words, which mean reduction and oxidation reactions. All right. So now, what is reduction? First, reduction simply means, now let's use the classic mnemonic that says Leo, the lion goes grr. Okay, let it go like this, grr. Like the sound of the roaring lion, grr. Is that okay? So Leo, the lion, goes grr. What this means was loss of electrons means what? Oxidation. Why this means gain of electrons means what? Reduction. All right. So oxidation has been defined as what? A loss of electron, and reduction has also been defined, on the other hand, has been defined what? As a gain of electron. So when an atom gains electron, it becomes reduced. And by reduction, we say that what? It gains a negative charge, for example. And when an atom loses electron, it gains what? A positive charge. Why? Because what? It has been oxidized when it loses electron. All right. So that's the first definition. Now, the second definition is that reduction is a decrease in oxidation number. while oxidation is an increase in oxidation number. Is that okay? So first, what is oxidation number? Oxidation number simply means valency. All right, okay, there's actually a difference between them. When we say valency, we are not really particular about the charge, but when we mean oxidation number, we mean to ask you the charge. Is that okay? You must include the charge. So for example, for sodium, for example, the oxidation number is what? +1. All right, if I ask you valency, you could just say 1, but if I say oxidation number, you should include the charge. Is that okay? Good. So now, what is now the effect of these things? If I ask you to find the oxidation number of a number amidst of an atom amidst a compound, how do you do that? For example, if I ask you to find the oxidation number of chlorine in for example, Al, and for example, KClO3, if I ask you to find the oxidation number of chlorine in this compound, how do you do that? First, what you must understand what is called the ground state and the excited state of a molecule. Excited state. Now, what is a ground state? It's very simple. Ground state means it is in the unreactive state. Excited state means it is in the reactive state. How do you identify them? When you don't see a charge, when you don't see a charge on the molecule, it is ground state. When you see a charge, it is excited state. So this guy is in what? It is in what? The excited state. And I've told you when we're doing chemical bonding that how many electrons will be there? It means 10. Is that okay? And this one is what? Is what is in the ground state. Why? Because it bears no charge. So when there's no charge, ground state. When there's a charge, is what? Excited state. And the ground state oxidation number is what? 0. When an atom or compound is in ground state, it has a total oxidation number of what? 0. Why this one has a total number of oxidation number that is equal in magnitude to the charge that you see on top. Is that okay? All right. So now, looking at this compound, let me write it. KClO3. So for example, we have to find the oxidation number of chlorine in this guy. We're going to have 1 plus oxidation number of this guy, which is 1. Potassium is 1 because it's number 19. And this guy, chlorine, we don't know, so we represent by X plus 4 into bracket, this 4 into bracket. What is the number of oxidation number of oxygen? It is -2. Everything should give us what? 0, which is the total oxidation number of this ground state. So we have 1 plus X plus 4 into bracket, this dot -8 equal to 0. So we have 1 plus X more plus times minus what? -8 is equal to what? 0. Is that okay? So here we're going to have X is running here, this guy goes here, this guy goes here. So we have equal to 8 when it comes here, and this one -1. Is that okay? So we have X will be equal to 7. So the oxidation number of chlorine here is going to be 7. All right. How about if I ask to find the oxidation number of chromate in K2Cr2O7? I say find the oxidation of chromium in this compound. What's the total oxidation number here too? 0, of course, because there's no charge here. Remember, the total charge that an atom has is the oxidation number of the atom. Is that okay? So what do we have here? K2Cr2O7 is going to become this. We're going to have 2 times, what's the oxidation number of potassium as we did here? 1 plus 2 into bracket. What we are looking for is chromium, right? 2 what? Into bracket X, that is 2X. Is that okay? Because it carries 2 here, 2 times whatever the oxidation number is what we're looking for. Is that okay? Plus O7, that is 7 into bracket what? -2, which is the oxidation number of oxygen. Is that okay? Everything must give us the ground state oxidation number of the entire compound, which is 0. So 2 times 1 is what? 2 plus 2x, 7 by this, -14 equals 0. So what do we have? This guy will go here, this guy will go here. So we have 2x left here. Is equal to 14 here, -2. Or you simply say you are adding 14 to both sides and subtracting 2 from both sides so that you have this. Is that okay? So you have 2x is equal to what? This minus this is 12. So you divide both sides by 2 and x becomes what? 6. And that is the number of what? Chromium there. Good. Having known how to find oxidation number, let's now go on to how to write balance a redox reaction. How do we balance redox reactions? Now, I'm going to write the set of rules that we follow in balancing redox reaction, because we can balance redox reaction in two media rather. We have the acidic medium and the basic medium. We have both acidic and basic medium. So the acidic and basic media. So we have a set of rules in which we use in balancing them. So for the purpose of this video, I'm going to pause and quickly write them here and continue. All right. So these are the rules of balancing a redox reaction. All right. So, but these rules are basically pertinent to acidic medium. Now, in basic medium, it's very simple. Now, when you balance an acidic medium first, all you have to do is simply add equal number of OH on both sides to neutralize, add equal number of OH to neutralize H plus. Is that okay? So, and you form water, and then you cancel out species that exist on both sides. But you're going to see what I'm going to do here. It's very simple. The first one says we should assign oxidation number to each atom in the equation. So let's assign oxidation number. So what is the oxidation number here? Because I2 is alone here. I2 is alone here. There is no charge here. So the oxidation number of this guy is what? 0. Is that okay? Now, S here. Now, you don't even have to check everything. Because once you see the species, once you have gotten the species that is oxidized, you will know the species that is reduced. Is that okay? The other species is the species that is being reduced. So in this case, since we are going from 0 to what is the total charge of this guy here, of iodine here, is what? -1. So from 0 to -1, is that a reduction in oxidation number or an increase in oxidation number? That is what? A reduction in oxidation number, because 0 is greater than -1. Here we have -1. So what does that mean? It means that there is a reduction here. Reduction has happened. So if reduction happened here, it definitely means that on the other side, oxidation happened. Is that okay? So we are going to write what we call the half equation. So since we have assigned oxidation number, the next step says we should determine what is oxidized and what is reduced. So this guy is being oxidized, this guy is being reduced, and this guy is being what? Oxidized. Then now we should split the overall reaction into half reactions. So let's split them into half reactions. We're going to have here, we have our reduction half reaction. So I put it as RH, our reduction half reaction. So in reduction half reaction, we went from I2 to I minus. Is that okay? And our oxidation half reaction, we went from S2O3 2 minus to S4O6 2 minus. Now make sure you write the correct question, because if you write a wrong question, you are going to balance it wrongly. Is that okay? So the next rule says that after splitting, we should balance atomically. Now it says we should balance oxygen by adding water. But seeing in this reduction of reaction, there is no oxygen, so we can just balance atomically. It means that balance the number of atoms. How many atoms of this guy do we have here? Of iodine do we have here? 2 atoms. How many do we have here? 1 atom. So what do? We come and add 2 here. Now, if you don't understand how I did this here, I'm going to link the video of how to balance chemical reaction down in the description. Is that okay? So, but this is the case where if the atom is 2 here, we basically add this number here, the molar number. Now, you cannot, I told you in that video of balancing chemical reaction that you cannot touch this number. You can only touch the number that is the mole here. You can only add the number here, and you cannot reduce, you can only add. Is that okay? So here, that's why we are putting 2 here. So 2 iodine here, 2 iodine here. That is atomically balanced. Now let's see. The next thing says you add hydrogen to, if there is hydrogen, there is no hydrogen here. Is that okay? So balance ionically now. So that is to balance the charges. That's the next thing. We have balanced the atoms. Now let's balance the charges. How do we balance the charges? What's the total charge here? Here it's carrying -1 from here. Is that okay? But now 2 has been added. You added it 2. Is that okay? So that is 2 times 1 is going to be what? -2. 2 times -1 is going to be what? -2. So how do we make it equal here? Because the total charge is what? 0. And here we already have -2. So what do? We are going to add electrons It says we should add what? Electrons. So by adding electrons, we are going to balance. But how many electrons do we have? We are going to be adding 2 electrons because electron is negative. Is that okay? But how do you even know where to add to? You know where to add them by checking the side with the highest number of charge. The highest charge is here, which is 0. The charge here is -2. So the highest number, you add electron to the side with the highest number. Is that okay? So this side is with the highest number 0, and this side is -2. So we'll come and add the electron to this side, which has the highest number. So how many electrons are going to add? 2 electrons. So that's here, we're going to have 0 plus -2 equals to -2. So this is what? Ionically balanced. Good. Now let's take the same process here. We are going to check assigned oxidation bars. We have assigned oxidation bar. The next thing is to check the balance now. We have split it rather. So let's see. Let's balance atomically. How do we balance atomically? How many atoms of sulfur do we have here? We have 2 atoms of sulfur and 4 atoms of sulfur here. So what do? We basically come and add 2 here. So that 2 times 2 here, 4s, and oxygen 6. 2 times 3, 6. That is balanced. Okay? Now let's check the charges. Because we are now, oxygen is balanced here, so we don't need to balance oxygen again. Is that okay? It now says that we should balance it unically. What's the total charge here? The total charge here is going to be 2 times -2, that is what? -4. And the total charge here is 1 times -2 is what? -2. So which side is higher? -4 or -2? -2 is higher, of course. So what do? We add electron to the side that has the highest number, right? So we'll come here and add what? How many electrons to equal -4? We add -2 to -2 to give us a -4. So that will be -2 electrons. Just think of electrons as negative charge because in fact, that is what they are. Is that okay? All right. So what do we have here? This is now ionically balanced and what? Atomically balanced. So what does it say we should do now? We can now combine the overall reaction. But before combining, we must make sure that these electrons are equal on both sides. Is that okay? We must equate the electron for both equations. The number of electrons for both equations. The reason is so that electron will cancel out. Electrons must not appear in our overall equation. So now, what do? Let's first try to write the overall equation. Because electrons will appear. So in the overall equation, in this case, so we'll look for a way to cancel it out. Now what do? Check if the electrons are equal in both sides. So electron is equal here, electron is equal here. Now this is one more trick to know. Once is your reduction half reaction, electron will be added to the left side. Once is the oxidation half reaction, electron will be added to the right side. Is that okay? Electron is added to the left side in what? Reduction half reaction. Electron is added to what? Right side in what? Oxidation half reaction. Good. So that's what one way to detect if you are correct or not. So here we're going to write the overall reaction. So our overall reaction. Now this is not the final overall reaction. Why? Because we are doing this to be able to cancel out electrons. So you watch me and see how I do it. So this is the right side. This is the right side. So let's write the right sides together. Because that was what we had in the beginning. So we have I2 plus 2E minus plus 2S2O32 minus. Standardly, I'm supposed to write this before electron, but either way you write it, as far as we're writing this side and this side together, plus. Is that okay? Then we are going to write this side and this side together. So to give what? This guy, 2I minus plus what? S4O6, 2 minus plus what? 2E minus. Is that okay? So what the rule says is now we should cancel out any species that appears on this side that appears equally on both sides. So 2E appears here, we cancel it out and cancel it out here. Is that okay? So no other species appears equally on both sides. So our final overall reaction becomes what? I2 plus what? 2S2O32 minus to give 2I minus plus S4O6 2 minus. And that is our answer. If you check well here, it is both ionically balanced and ionically, and it's both atomically balanced and ionically balanced. And we can check together. I is 2 here. S is 4, O is 6, O is 6. Charges, let's check the charge. Total charge here, 0 here plus -4, that's -4. Here, -2 plus here, -2, that's what? -4. So it is both atomically balanced and ionically balanced. And this is what? Our balanced redox reaction. All right, I'm going to write a second question, and that will be it for this video. All right, this is the second question. Now, what's the trick I'm going to use? The best way to be able to be faster in this case is just go and check the lone atom. This one is a single atom here. So once you go to the lone atom, you can decipher the oxidation number immediately. Since it's not carrying any charge, it means that the oxidation number here is what? 0. We have assigned oxidation number. So on this other side where Al appears, we can't check it here because Al is not here. So Al appears here. We're going to check the oxidation number. What happens to the oxidation number here? It's going to be X plus, using the principle we did the other time to find oxidation number. X plus what? O2 minus. So, and 2 is what? Already minus 2. Remember that 2 times minus 2 is the oxidation number of oxidation of oxygen is minus 2. So 2 times that minus 2, is that okay? Is equal to, what's the total charge here? Is minus 1. But is that okay? So that X plus 2 times minus is what? Minus 4. Is equal to what? Minus 1. So we have X is equal to what? Minus 1. This comes here to become plus 4. So we have X is equal to what? Plus, this is basically 4 minus 1. That's what? 3. So what happened? The oxidation number went from 0 to 3. That's what? An increase in oxidation number. And that is what? Oxidation. When the oxidation number increases, that is called what? Oxidation. So from here to here, we have what? Oxidation. While from here, it means from here to here, what? Reduction. Is that okay? So we have determined which one is oxidized and which one is reduced. Now, we now split the overall equation. So let's split the overall equation. Let's start with the reduction. We have reduction half reaction and the oxidation half reaction. So in the reduction half reaction, what do we have? We have from NO2 minus to NH3. There's no charge. Al to AlO2 minus. All right. Now, the one thing about redox reaction is that the more you solve, the more trick you decipher, you unlock in solving them. Is that okay? And the faster you are, of course. So in this case, what does it say we should do? We should balance atomically. Now, see here that we have nitrogen here, one nitrogen, and one nitrogen there. Okay, how about hydrogen? We have hydrogen here, but we don't have hydrogen here. And we have oxygen here, we don't have oxygen here. So what do? We go to the rule. It says we should balance oxygen with what? By adding water. So how many oxygen do we have here? How many oxygen do we have? We have 2 oxygens, right? So how many water are we going to add? We are going to add 2H2O, 2 water, so that it will equate what? 2 oxygens. Is that okay? 2 water. 2H2O is going to give us 2 oxygen. Is that okay? Then hydrogen has now become 2 here. Is that okay? 2 times 2, 4, plus 3 that we had here. Is that okay? That becomes 7. So here we're going to add plus 7, 8 plus. How do we balance hydrogen? Remember? By adding what? 8 plus. So we're going to add 7H plus there. Is that okay? Good. So from here, we can therefore now check if it is balanced ionically. Because from what I'm seeing here, it is balanced atomically. Now let's check again. 1 nitrogen, 2 oxygen, 4 hydrogen, 4 hydrogen plus 3, 7 hydrogens, and 7 protons here. Is that okay? So here we're going to have the total charge. Let's check. Here, the total charge is minus 1. Is that okay? So minus 1 plus, the total charge here is plus 7. That is plus 7. Is that okay? That is minus 1 plus 7 is equal to what? 6. So total charge here is what? Plus 6. Positive 6. Then on this side, it is 0. Because this one is 0, this one is 0. So what do? We add the electron to the side that has the highest charge. Is that okay? So the highest charge is on this side. So we are going to add what? Electrons. So let's add electrons here. How many electrons are we going to add? The number of charge we have here is 6 charges. So we're going to add 6 electrons to cancel out the charge to make it equal to this side. So we add what? Plus 6 electrons. Is that okay? Plus 6 electrons. So on this side, we're not going to add anything. And that conforms to the rule I told you. That is reduction, the electron is added to the what? To the left side. And oxidation, electron is added to the what? To the right side. Is that okay? So let's come here. So this is atomically and ionically balanced. Let's come here. Aluminium is 1 here and it's 1 here. But oxygen is here, is not here. So what do? We add water. How many water? 2 oxygen equals what? 2 water. Just as we had here. Is that okay? Now we have introduced a new species here, which is hydrogen, which was not here. So what do? We'll come and balance that. We're adding what? How many hydrogen in this case? 4 hydrogen, 4 protons, 4H plus. Is that okay? So now, what do we have here? We now balance ionically. Let's balance ionically. How many charges do we have there? 0. How many charges do we have there? -1 on this side, +4. That's what? +3. So what do? We add electrons to this side because it has the highest charge. Is that okay? So this becomes, we are going to add how many electrons? 3 electrons. So cancel it out so that -3 plus 3 minus 3 is going to give us 0. Plus 6 minus 6 will give us what? 0. Good. So what we have here, so we now have it both atomically and ionically balanced, and both are ionically and atomically balanced. Good. So what do we do from here? We're not going to write the overall reaction. But before we write the overall reaction, remember I told you that you must equate the number of electrons on both sides. How do you equate the number of electrons on both sides? Let's multiply this side by an integer number that can equate this. Is that okay? Now, how do we do that? Now, since 6 electrons here and 3 electrons here, how can we make 3 electrons equal 6 electrons? What we basically do is what? Multiply this one by 1. So if we multiply this by 1, it gives us the same thing. And multiply this one by what? By 2. Is that okay? So if we multiply everything here by 2, what we have is what? 2Al plus. So if we multiply this equation by 2, we are going to equate it to this one. So we are going to have this 2Al plus 4H2O to give us 2AlO2 minus plus 2 times this 8H plus 2 times this 6E minus. So with this, we have equal number of electrons, so we're going to have this take care of this. Is that okay? So what do we have there? We're going to write our overall equation. So we're going to write this first one without the electron, of course, because the electron has cancelled. This first one plus, we're going to write this first one plus, because this is the left side, this is the reactant side, and this is the reactant side. So reactant first. So we're going to have here NO2 minus plus 7H plus. Remember, it was 1 we used to multiply this, so it didn't change it. Then plus this side. I mean, this side now, because this side has turned into this guy. This side. Is that okay? Because we multiply by 2, so this is what we newly have. 2Al plus 4H2O. Is that okay? Then to give us this right side and our new right side. Is that okay? So we have NH3 plus 2H2O plus this guy 2AlO2 minus. There's a minus there. Plus 8H plus. All right, and this will be our overall redox reaction. And let's check if it is actually balanced both atomically and ionically. For example, here we're going to have